Okay guys, here's the first side of the geometry review packet for Unit 8. Let's jump right in. At the top you'll notice it says make sure you know the names of polygons from triangle to decagon. So let's go through that really fast. A figure with 3 sides is going to be a triangle. 4 sides is going to be a quadrilateral. 5 sides is going to be a pentagon. 6 sides is going to be a hexagon. 7 sides is either going to be a septagon, or sometimes you'll see it as a heptagon. 8 sides is a octagon. 9 sides is a nonagon. And 10 sides is a decagon. So remember, we have a couple of formulas for topic 21. You need to memorize these. The sum of the interior angles is n minus 2 times 180. Remember, we broke up our shapes into triangles. Each triangle's angles add up to 180. For any given polygon, there's 2 less triangles than there are sides. That's where the formula came from. Okay, so if we want to find the sum of the interior angles for a decagon, since n is 10, we're going to have 10 minus 2. I'll do this in red really fast. We're going to have 10 minus 2 times 180. That's 8 times 180, which gives us a grand total of 1,440 degrees. Okay, for a hexagon, we have 6 sides, so 6 minus 2 times 180. That's 4 times 180, which is 720 degrees. For a septagon, that's 7 minus 2 times 180, so 5 times 180, which is 900. If we want to figure out what just one interior angle is, as long as it's a regular polygon, which means all of the interior angles will be congruent, we take n minus 2 times 180, and we divide by the number of sides. So notice we already have our total. It's 1440. If I divide by the number of sides, which is 10, I'll get that each one is 144. So I've already done n minus 2 times 180. I got 720. My total is 720. I divide by the number of sides, or the number of angles. I get 120. Again, I'm going to do 900 divided by 7, because 7 is the number of sides, which gives me 128 point, we'll just round it to the 10th, so 6 degrees. Well, one exterior angle, a regular polygon, well, all the exterior angles add up to 360. If we want 1, we divide by n. So I'm going to do 360 divided by 10. That will give me 36 degrees. Here I have 360 divided by 6. There's 6 sides. And then here I have 360 divided by 7. I have 7 sides. Okay. Now you'll notice, remember from class, one interior or one exterior angle, they're going to add up to 180. And you'll notice that these add up to 180, these add up to 180, and these add up to 180. So remember, one interior angle and one exterior angle always add up to 180. They're a linear pair. Okay, let's keep moving on. So number 2, solve for x. Well, remember we have 2 steps. Our first step is always to solve for the total. Well, the way we find the total of what all these add up to, or the sum, if you would rather use the word sum, of the interior angles. We're going to take n minus 2, so 6 minus 2 times 180. That gives us 4 times 180. That gives us 720. That means, so like I said in my equation, 720 is equal to x plus 120 plus 90 plus 135 plus 135 plus 90. And if I do 120 plus 90 plus 135 plus 135 plus 90, I get 570. If I subtract 570 on both sides, I get 150. So my x here is 150. So remember, I started by finding the total. What do all these need to add up to? That's based on n minus 2 times 180. and then I can set them all, add them all up. Okay, for number 3, what I'm really just looking for is one interior angle of a regular polygon. Notice all the sides are the same. I really should have also marked that all the angles were the same, because in order to be regular, all the interior and exterior angles are congruent. But we have a formula for that. It says take n minus 2 times 180 to get the total. If we want just one of them, we divide by the number of sides. There's 8 sides, so I have 8 minus 2 times 180, dividing by 8, because there's 8 sides. So that's going to be 6 times 180 divided by 8. And I get one of my interior angles to be 135 degrees. Okay, for number 4, we need to find the value for x, y, and z. We're going to assume that this is a regular hexagon and a regular quadrilateral, although I should have mentioned that. I should put that in the description. Well, if this is a regular quadrilateral, we know that if they all add up to 360, each of them will be 90. So z will be 90. For x, we can say, okay, well, the total is going to be n minus 2 times. I want one of the angles, so I divide by n. So that'll be 6 minus 2 times 180 divided by 6. So that'll give us a total of 120 for x. Here's where it gets a little tricky. All of these are going to be 90. All of these are going to be 120. And whenever I can make a circular shape, or if 3 angles or any number of angles add up to a full circle, they're going to add up to 360 degrees. So I can say 90 plus 120 plus y is equal to 360. So that's going to give me y plus 210. So I'm going to get y equals 150. So the big takeaway from this is whenever I can make a circle shape with my pen, and notice this fills up the whole circle, that's going to be 360 degrees. Okay, on to number 5. Because if one exterior angle of a regular polygon measures 20 degrees, so one exterior angle, here's my exterior angle. What is the measure of one interior angle? Well, we know that an interior and an exterior angle add up to 180 degrees together, which tells me that this has to be 160. And the way I can do that is just do 180 minus 20, and I get 160 degrees. Well, how many sides does it have? We have a couple formulas that can help us solve for n, but the easiest one is to say, well, we already know how much one exterior angle is. One regular exterior angle is equal to 360 over n. Well, we know that one exterior angle is 20. I can multiply by n on both sides and then divide by 20, and I get 18. So there's 18 sides for this shape. Okay, I'm going to start working on another one for you guys.